Hello from Edmonton, Alberta, Canada, and thank you for your interest in Terrapin. My name is Gray Alton, and I'm the Vice President of Project Development for Terrapin. In this video, I will be walking you through an introduction to who Terrapin is and what we do. I will also introduce the three verticals of the types of projects we develop, along with what technology we use. I will also be giving details on some of the exciting investment opportunities into two projects that we are developing in North America. Terrapin is a heat-to-value project developer who was founded in 2016 because we kept asking ourselves this question: how are we supplying reliable heat and power to the innovating world? We have seen a number of governments and corporations making carbon neutral commitments by 2045 or 2050, but there are no concrete solutions on how to get there. So a bit more detail on what the problem is that Terrapin's trying to solve. As mentioned previously, with the carbon neutral commitments that the world is making, we are going to need an increase in baseload clean power and heat for our cities. And by baseload, meaning consistent supply of heat and power. There's also a large opportunity given the amount of heat our global economy wastes every year. And I do want to say that even though we waste 290,000 petajoules of heat every year globally, not all of this heat is able to be captured for use, but there is a large portion of this 290,000 petajoules that can be converted and useful. Lastly, there are vast amounts of opportunities to harness industrial or geothermal heat and power, but there are not a lot of firms focused on industrial and geothermal heat recovery in relation to the other clean tech industries. And so Terrapin wanted to focus in this area. As a heat-to-value project developer, Terrapin is innovating the identification, development, and delivery of these three heat-to-value verticals that you see on the screen: waste heat to power, innovative direct heat use opportunities, and geothermal heat and power. Both our industrial waste heat and geothermal verticals on the left and right represent the power generation solutions that Terrapin can bring to our clients. We use an organic Rankine cycle technology, which I will touch on more later, to convert that recoverable heat that resides within your industrial facilities or from kilometers below our feet in geothermal formations. I will also be going into more detail on the characteristics of the waste heat streams and geothermal projects that we look for in a few slides. In the middle, you will see our direct heat use vertical. Based on the temperature profile of this vertical, this is the most commonly found waste heat that we find at industrial facilities. Direct heat use is also available after the power generation process for both our other verticals, and I will go into more details about the direct heat use characteristics in a few slides. So I want to go a bit deeper into explaining our three verticals at Terrapin. If your project qualifies, Terrapin has the ability to access third-party capital to develop your waste heat to power project, where Terrapin and our capital partner can offer the facility owner a zero CapEx option and a gross revenue royalty payment for access to the waste heat to construct an independent power project, where Terrapin and our capital partner can sell the power back to the facility or wholesale it to the power grid as a vertically integrated utility. Terrapin is also able to fully develop a project that is to be paid for and owned by the facility as well, or we can simply just sell our technology to that facility owner for their own development. For industrial facilities that are close to city infrastructure, Terrapin has the experience in connecting direct heat use networks to municipal and city infrastructure via district heat networks. This is where facilities that produce an abundance of waste heat that can't be used for power can sell it to a neighboring facility that currently uses a hydrocarbon-based resource to provide heating for things like drying, preheating, or boiler systems, greenhouse heat. There's a lot of different uses for it. Terrapin also has a globally qualified team of geothermal developers backed by years of experience. Terrapin can scout out geothermal fields for power and direct heat use development opportunities, and we can perform all exploration and completion activities. Terrapin has also consulted to governments, municipalities, and cities to explore local geothermal opportunities and their best use cases. And our experience is backed by being the first company to be awarded and developing the first conventionally drilled geothermal power project and direct heat use project here in Alberta, Canada. Terrapin is the linchpin that brings the entire development team together to make these projects work. We align the waste heat owners, technology partners, third-party capital providers if needed, and the EPC construction partners to construct turnkey industrial waste heat recovery and geothermal heat and power projects. As a vertically integrated project developer, Terrapin has the ability to manage the entire process to identify, conceptualize, and if needed, invest in your heat to value project. Or Terrapin can consult for any phase of the development along this pathway. I now want to talk a bit about our traction. On the left, you will see the legend that shows our Tier 1 and Tier 2 projects in development. The Tier 1 projects represent the 2 investment opportunities that I will be speaking about in this video a little bit later. Those are a geothermal project in Northern Alberta and a suite of 9 waste heat to power projects in Texas and Colorado in the US. The Tier 2 projects are represented here are projects that are under an NDA and have gone through a data exchange process, so Terrapin can size the prize of the opportunity and conversations are ongoing. Feasible market growth and future market potential represent Terrapin's 2, 5, and 10-year plans as a company, and we've had good traction within the oil and gas industry here in North America and Europe, and Terrapin has been gaining more traction within the heavy manufacturing, steel, cement, glass manufacturing, parts manufacturing, the utilities, pulp and paper, even the agriculture and food production industries. Southeast Asia is our most recent expansion territory, and we are very excited to be here. We are certainly excited about the opportunities that are available for waste heat and geothermal development, but our greatest excitement is from being able to surround ourselves with such a forward-thinking and motivated ecosystem to make the energy transition a reality. Terrapin has built a specialized and industry-tested team to get us where we are today. Our team members are backed by extensive, applicable backgrounds of proven success that they bring to Terrapin every day. We have grown to 7 full-time staff, 5 consultants, and we have an extensive network of contractors that we engage with as required by our projects. The Terrapin team has consulted with governments, municipalities, professional associations, and within private industry, and our experts within the waste heat recovery industry and geothermal industries are highly regarded as, and we believe it's been proven through our corporate experience and track record to date. Terrapin also believes we are on the right path as a company and have the right track record because of the support we've received to date. We are truly grateful for the opportunities that Terrapin has been presented with due to our affiliations with the partners shown here. And I specifically want to highlight 2 partners. First is RISE. This video would not be required if not for RISE. We want to thank the entire RISE team for their support, and we look forward to our continued relationship with them. The second is our partnership with the Canadian federal government's Trade Commissioner Service. This is a partnership that gives Terrapin access to the Trade Commissioner Service's international offices and their local partnerships to support our global growth, and we look forward to working with them as well as RISE to grow our footprint in the Southeast Asia region. So now let's get into the more technical side of our business. And I'll be starting with waste heat recovery in industrial settings. I previously mentioned the type of industries that Terrapin has been gaining traction in, specifically oil and gas, heavy manufacturing, steel, cement, glass manufacturing, utilities, pulp and paper, and the agriculture industries. And one of the things you should gather from this list is that Terrapin is industry agnostic when it comes to heat recovery. This also means that the type of equipment assets that Terrapin can recover waste heat from is quite diverse. Terrapin anchors our search around meeting specific technical characteristics of the waste heat stream and the overall project that we need to achieve in order to make sure that the project will be viable and profitable. Some of the sources from where we can cover waste heat are gas turbine drivers that reside on pipeline compression, power generation, or residue gas recompression. We can capture waste heat from large industrial furnaces, process streams, cooling loops, and high pressure steam systems. But again, that's not a comprehensive list. So what are those technical considerations that Terrapin looks for? Well, first we focus on the specific waste heat stream. We need to know the temperature of that waste heat resource. For waste heat to power generation, we typically look for anything between 120 degrees Celsius up to 500 degrees Celsius. And the flow rate is highly dependent on the temperature. For example, At 463 degrees Celsius, we would need around 82 kilograms per second in flow rate of the waste heat resource to be able to generate power. As that temperature drops, the flow rate requirement goes up if we want to create power. For the waste heat resources below 120 degrees Celsius, Terrapin would look to use this resource as direct heat use. Here, we would first explore if the facility that is producing the abundance of waste heat. We need to look to see if they are in need of any direct heat use anywhere within their facility footprint. This can be preheating, drying, boiler heat, or anywhere where there is combustion of hydrocarbons for heat use. If no direct heat use opportunities are available within the facility, Terrapin would then turn our attention to the neighboring facilities within a 5 to 7 kilometer radius and explore a district heat network. If the facility with an abundance of waste heat resides within an industrial cluster or is close to city infrastructure, there could be the opportunity to sell that lower grade direct heat over the fence to a neighboring facility. The state, stability, and availability of the waste heat stream speak to the requirements of Terrapin's waste heat recovery process to be supplied with a consistent waste heat resource that is not too dirty with particulates that it might plug up our heat exchanger. We scout waste heat resources that can supply a consistent flow of waste heat, which means that equipment asset needs to be running for a minimum of 80 to 85% of the year, so we can achieve a baseload supply of heat and power. Certain aspects of the site characteristics, such as plot space requirements, can be mitigated by the flexibility of how we can deploy our waste heat to power technology within your facility. All we need is that our heat exchanger be within 10 meters or as close to that waste heat resource as possible. But after that, we can design the waste heat to power facility to fit within the footprint of your site. What's most important to know here is the future plans for expansion, maintenance, or asset replacement programs. Terrapin looks to develop 20-year and longer heat to power projects. And so if the equipment is only in operation for, say, 5 years, it may be tough to justify the capital expenditure for the project. Lastly, Terrapin is always in evaluation of the economic and policy characteristics of where the project will be located. Can we get the power to the grid? Can we sell the carbon offsets? What are the regulatory requirements for power generation? And are there any other aspects depending on the project details and where the project actually resides? These are all very important characteristics. Terrapin uses the decades-long established organic Rankine cycle technology for waste heat to power production, or ORC for short. ORCs have been in operation since the 1980s, but in the last 10 to 15 years, the technology has made advancements, making it a more efficient heat engine for a more competitive cost. As you can see here, we would integrate a heat exchanger into the stack that emits the waste heat and install a bypass damper. That waste heat is diverted into the ORC heat exchanger, which transfers the heat into the closed loop ORC working fluid, which is represented here with heat in. From here, the working fluid is evaporated and passed through our turbine, which outputs emission-free baseload power, which is illustrated by the power out. The ORC uses aerial cooling to condense the working fluid back into liquid form, which is represented by the heat out logo. And then that working fluid is pumped back to the heat exchanger to be reheated and to begin the process again. The power in to run the pumps comes from the ORC facility's power production itself. There is no external power required to operate the ORC power production process, and the unit is entirely self-sufficient. I also want to point out the use of aerial cooling versus water cooling for our power generation process. Terrapin believes this is a big advantage in the power generation space, specifically for water-constrained regions or remote sites. I mentioned earlier that we look for waste heat resources up to 500 degrees Celsius. We set this upper limit because if the waste heat stream is any higher, it will degrade the working fluid of the ORC too rapidly to justify ORC use. In these cases, Terrapin recommends looking at steam power generation if you have access to water cooling at your site. Terrapin is focused on ORC power generation versus steam power generation. because the properties of the organic fluid allow a simpler turbine and cycle design to be used, which is more cost-effective at a smaller scale. And the properties of the organic fluid allow a larger mass flow rate to be used, which leads to a physically larger turbo machinery, which is inherently more efficient. And organic fluids have less energy to release in an explosion in the rare occasion that a catastrophic failure occurs. This slide is going to illustrate the temperature ranges that we seek out and what the power potential output could be in these temperature ranges. This graph is based on historical operational data, so I'm always careful to say that the final output of the ORC facility is very locational dependent, and so this graph is for informational purposes only. But you can see here that typically Terrapin's power generation projects fall in the 3 to 10 megawatt range, depending on the site conditions. Terrapin does not own the organic Rankine cycle technology. We have negotiated an exclusive distribution agreement with Exergy, a 10-year-long established ORC designer and manufacturer based in Italy who owns the IP for this ORC technology. In 10 years, Exergy has built over 50 projects around the globe with almost 500 megawatts of power being generated. Exergy's ORC technology has also averaged a 99.3% uptime availability, meaning as long as there is a waste heat resource available, the Exergy technology will be producing emission-free baseload power right alongside it. I previously mentioned the flexibility of the placement of the ORC technology. We have provided a typical deployment of the ORC that you can see here, but this is by no means the only way to deploy this technology at a facility. The Exergy technology has been designed to take up a minimal footprint, and the equipment can be placed on ground or be suspended in the air even if required. We choose to work with Exergy because of these characteristics and advantages seen here. Along with their proven track record of success in 10 years, they bring a solid ORC power facility and the ability to be able to be flexible with the design and placement of the facility, and they have competitive operating costs, which lead to faster payback periods, and they can work with a variety of operating temperatures. So now it's time to talk a little bit about geothermal. First, we want to clarify what scopes we work with when talking about geothermal. There are several notable uses within the geothermal industry. Terrapin is focused on conventional geothermal power generation and direct heat use. This means we generally have to drill to access our geothermal resource, which can be anywhere up to a 5-kilometer drill in depth. But this is a highly locational dependent number. Here in Alberta, in Canada, we are drilling a 4.5-kilometer well to reach our geothermal resource, where in regions like Southeast Asia, that depth is much shallower. The Terrapin geothermal team is backed with years of global experience in developing geothermal dry and flash steam power plants in regions such as Iceland, South America, and China. But due to the large amounts of developers focused on the steam generation space, Terrapin is largely focused on the binary and direct heat use aspects, binary power production and direct heat use aspects of geothermal development. I will say that we will never walk away from a viable dry or flash steam opportunity if a geothermal field presents those metrics. But by using ORC to generate power from lower grade heat, again in the 120 to 500 degrees Celsius range, Terrapin can harness the waste heat left over from a dry or flash steam generation process, where we can help improve the overall power production and efficiency from an existing facility and well. But the ORC technology can also stand alone as its own geothermal facility if required. And our technology partner Exergy has many operating ORC geothermal power facilities. The principles of geothermal direct heat use are the same as I presented with the industrial waste heat direct heat use. For geothermal heat that falls below that 120 degrees Celsius that we cannot generate power with, Terrapin can redistribute the waste heat up to 5 to 7 kilometers away from the original source that can be used as direct heat to offset any hydrocarbon heat use. And I will go into a little bit more detail on this in a couple slides. The Terrapin team has the experience to scout out geothermal opportunities in the regions that are best for development. We can conceptualize the best use of that geothermal resource. We can design the exploration and production wells, along with managing the well, drilling, and completions activities. And we can also design and construct the power facility and direct heat use network as well. Once the best geothermal field has been identified and a location is secured, an exploration well will be drilled to bring the geothermal brine to surface for temperature and composition testing. If deemed viable to proceed, a second exploration well will be drilled where the geothermal brine will be further tested for temperature and composition consistency, along with testing the flow rate to confirm that power generation will be possible. Based on the site-specific temperature and flow rate, the ORC power facility or steam generation facility will be designed in order to suit the site. And as the power facility is being manufactured, the large bore production wells that will provide high flow geothermal brine to the power facility will be drilled, along with a single or multiple reinjection wells, multiple kilometers away from the production wells as well, so we don't deplete the geothermal resource. Upon completion of the construction of the facility, the development will be interconnected to the local grid, and if there are direct heat use opportunities, a district heat network would be constructed to supply consistent geothermal heat for direct heat use opportunities to offset any hydrocarbon heat. And don't forget that geothermal is a renewable, clean, emission-free resource of power and heat. And the geothermal industry is placing great importance in the use of geothermal heat along with power generation. This is a repeat slide from the industrial waste heat portion of this video, but I will re-explain it just in case someone viewing this video only joined in for the geothermal portion. Terrapin uses the decades-long established organic Rankine cycle technology to generate power, or ORC for short. ORCs have been in operation since the 1980s, but in the last 10 to 15 years, the technology has made advancements, making it a more efficient heat engine for a more competitive operating cost. As you can see here, we would integrate a heat exchanger into the stack, but in geothermal, we would essentially just bypass and collect the waste heat after power generation if possible. That waste heat is diverted into the power generation process and is transferred into the closed loop ORC working fluid, which is generated here with the heat in logo. From here, the working fluid is evaporated and passed through the turbine, which outputs emission-free power, which is illustrated by the power out icon. The ORC uses aerial cooling to condense the working fluid back into liquid form, which is represented by the heat out. The working fluid is then pumped back to the heat exchanger to be reheated and begin the process again. In the power out, or in the power in to run the pumps, that power comes from the ORC facility itself. There's no external power required to operate our ORC power production process, and the unit is entirely self-sufficient. I do want to point out that the use of aerial cooling versus water cooling for our power generation process, Terrapin believes this is a big advantage in the power generation space, especially for water-constrained regions or remote sites. Last up is our technical introduction for direct heat use. This is an extremely important category when discussing industrial waste heat or geothermal. As you can see on the left, more than 60% of our global energy needs are spent on heating. And when we discuss renewables, there's great inherent values to using wind and solar, but neither of those processes can provide a base load resource of consistent heat, which is going to be very valuable in reducing fossil fuel for heating requirements. The geothermal industry in Canada has especially been putting great importance on direct heat use for space heating, as it is one of the greatest needs considering our winters here in Canada. But in places like Southeast Asia, this can still prove to be great value, even if space heating is not the greatest need like in Canada. In the industrial waste heat portion of this video, I've spoken about how to develop a direct heat use network. And when talking about direct heat use in geothermal, the principles are the same as geothermal power production and direct heat use in industrial use. Even if you were to drill a well for direct heat use only, it's the same delivery as geothermal power production. Once the geothermal field has been identified and a location secured, an exploration well is to be drilled to bring the geothermal brine to surface for temperature and composition testing. and if deemed viable to proceed, a second exploration well will be drilled where the geothermal brine will be further tested for temperature and composition consistency, along with the testing of the flow rate to confirm that we can produce direct heat. Based on the site-specific temperature and flow rate, the requirements of the locations off taking the geothermal direct heat, the district heat network would then be designed and manufactured. While manufacturing is going on, the large bore production wells that will provide geothermal brine to the direct heat use facility will be drilled, along with a single or multiple reinjection wells multiple kilometers away from the production wells. From here, it's a closed loop system that is producing base load, clean, renewable heat. I want to quickly talk about the direct heat use off-takers for a minute. This is not a comprehensive list of the possible uses of industrial waste heat or geothermal direct heat use, but we wanted to illustrate that there are vast opportunities that should be considered. I've said it a few times now, but Terrapin truly believes that the geothermal heat and industrial direct heat should be strongly considered when looking at reducing fossil fuels for heating requirements. Now let's talk about the fun stuff, investing. With our rapidly increasing pipeline of leads and development projects, Terrapin is not currently focused on raising into the main corporate entity, except in the case of a major strategic investor. Instead, we are focused on raising funds for both our Tier 1 projects currently in development. First is the Alberta No. 1 project, located 20 kilometers south of Grand Prairie here in Alberta, Canada. This will be the first conventionally drilled geothermal power and direct heat use plant in Alberta and possibly in Canada. The total project cost for the power plant and district heat network is $77 million, 25.45 of which is funded by the Canadian federal government's NRCan Emerging Renewable Power Program. The project is a limited partnership between Terrapin and the MD of Greenview, and Terrapin has secured PCL as an equity participant in engineering, procurement, and construction partner. And we are currently finalizing the equity participation of an Alberta-based drilling firm. The Alberta No. 1 project is split into 4 phases. We are looking for $10 million of equity participation for the exploration drilling phases of the project, expected to commence in Q4 of this year. Terrapin will also entertain conversations for larger investments into the project if there is interest, or if you're interested in later phases. So please contact us if you wish to get more information. The second investment opportunity is a portfolio of 9 waste heat to power facilities, capturing waste heat from the flue gas of operating turbines at gas compression stations. There's 1 project in the Midland, Odessa region in Texas, USA, and 8 projects north of Denver, Colorado, also in the USA, with a total potential output of 33.7 megawatts for all the projects. This project will be staged with the completion of the Texas project first, and then the completion of the 8 additional projects in Colorado. The capital cost for phase 1 is $30 million, with a total portfolio cost of $150 million. The equity available for the first phase is $20 million, but like geothermal, Terrapin will entertain other equity positions in the conversation. So if there's interest, please reach out. That is the end of our presentation on Terrapin. I certainly hope you learned a lot, not only about what Terrapin is doing and what we're working on, but hopefully you learned something new about industrial waste heat recovery or the geothermal industry. Thank you for your time, and please reach out with any questions or if you have interest working with Terrapin, and please pass this video on within your company or your personal network. Thank you.